Good morning, students. So even today we are going to see about medical electronics. So I am Saravanan. So today we are going to handle one title in medical electronics. So before going to that, let's see what we have seen so far. Brief, right? So we started with introduction. So we started with why medical electronics, what is the need of medical electronics, where medical electronics is applied, and what changes medical electronics has done to the current society. So then we saw about infrared thermometer. So we use every day in this lockdown period. So we saw the principle of operation and everything. And then we saw about the origin of biopotential. Means we started from the scratch. So we saw how ionic current comes out of the body and picked up by the electrodes, and then it goes to the bioamplifier. We saw what are the types of bioamplifiers and how to design bioamplifiers and so on. Then we slowly stepped into designing of biomedical recorders. So 2 days back we saw electrocardiogram. Yesterday's cycle we saw about electroencephalogram. Even today we are going to see about another biomedical recorder. So that is nothing but it is electromyograph, or it is also called as electromyogram. Electromyogram is the process of recording the biological activity associated with the muscle. So the output of electromyogram is a graph or a plot. So that's what actually. So electro, the word says about the electrical impulses, and myo means muscle. So graph means it's a plot of electrical activity that is associated with the muscle movement inside the body, right? So let's get into the session. So one line principle, so bottom line principle of this electromyogram or any biomedical recorder is simple. So we have already seen. So there is ionic current inside the body. We need to pick it and we need to convert it into electronic current. So we need electrodes. The electrodes are connected to the body, right? So from there it goes to amplifiers. For example, in EEG we had filters also, notch filter, low pass filter, high pass filter. So together we call it as signal conditioning unit. When the signal is being conditioned, we give it to the recording system. So the recording system may be a plotter, or it could be an oscilloscope, or it could be a digital recording. For example, today we are not going to plot anything. We will see why. Right? So this is what actually electromyogram is all about. So what do you see? You see this person is the doctor, patient. So there are electrodes here and here. So from electrodes it goes to the oscilloscope or some recording device. So there the doctor is visualizing. So this is the setup actually. So the recording will not be in hand alone. It can be in any part of the model which is under motion, right? Even athletes makes use of it, right? So why electromyogram is required means to understand or to analyze whether there is a nervous damage or artifact, something like that, right? So we'll get into the block diagram. So initially if you see, there is a human body. Say for example, like in the previous case, we have taken the electrodes and placed it in the hands. So that's why I have done. So we have placed so many electrodes in the hand. So there are muscles. So from here it goes to bioamplifier. So bioamplifier is needed because microvolt per millivolt signal need to be converted into voltage. So that is the main reason of bioamplifier. So bioamplifier includes instrumentation amplifier, differential amplifier, if necessary, filters also, right? So to avoid the artifact signal, that is the noise signal, and take up or pick up only the required signal. From here, if you see, there are three possibilities of output. So one is you can monitor lively using an oscilloscope. So why oscilloscope is required? Oscilloscope is a time domain representation display. So there you can lively watch it, or there is another option. You can see that. So you can give it to an audio frequency amplifier and then to a speaker, and you can hear what is happening, right? And there is another possibility that you can give it to a magnetic tape recorder, or nowadays optical disc or a flash memory. So this has changed. So no more tape recorder. Now there is a question comes: what is the difference? Does electro here we don't have a plotter anywhere. We simply have a live display, and then we can hear it and we can also record it. This is because the frequency generated from the muscle, the signals of the frequency generated from the muscles is about 15 kilohertz. That is the difference. 15 kilohertz is a very high frequency, so that you cannot plot. It moves very fast, so you cannot plot 15 kilohertz. But it falls under the audible frequency range, 20 to 20 kilohertz, right? So in that 15 kilohertz comes in the audible range. So you can listen to what is happening when the muscle expands and contracts. So that is why we have a audio amplifier and a speaker. Why audio amplifier? Because it needs to drive the speaker, right? The speaker might be 8 ohms or 16 ohms. It's a loudspeaker, so you need to have an audio amplifier. So that is as simple as that. So today's title or the block diagram is not so complicated. You have electrodes, the signal is picked. From there it goes to bioamplifiers. From bioamplifiers you can directly visualize in oscilloscope, or you can give it to a tape recorder or a magnetic or an optical disc or a flash memory, and you can also give it to loudspeaker, audio frequency amplifier and loudspeaker. So that is as simple as that. So is the principle clear? Yes. We'll move on. Here you can see that I have brought a live demo of. See, when he is pressing, you can get a signal here. The speaker is not connected, so I'll try to show it to you in my mobile for the viewers. You can see that it changes, the ring changes, the waveform also changes. So, let me show it to you.
And squeeze the hand grip while simultaneously recording your EMG signal.
You can see that the sound.
As you lose strength, the EMG amplitude and fire rate also diminishes. If you have access to a hand dynamometer, you can simultaneously measure the force.
So when he's pressing, yeah, it changes.
You squeeze the tool for as hard as you can for as long as you can. You'll notice the force output decrease as well as changes in the EMG signal itself.
So this is how they need to visualize. So before going to activity, so I'd like to tell you one drawbacks of this. One merit is that we can lightly hear what is going on, right? But there is a drawback in the system. What is the drawback? Only the expert doctors can hear and find out what is the abnormality. That's not the case in the previous one. So you need expertise person in this field to exactly find where the changes happens, because it's audio signals, it goes faster. So to diagnose, you need expertise in this field. So that is the only limitation of the Electro Myogram. So this is the activity we have planned today. So one batch of students need to be formed. So what they need to do is they need to generate at 20 Hz to 15 kilohertz. This is because an audible frequency. So you need to generate a signal using oscilloscope. What you will do is you will simultaneously give it to a function generator like it happened in the video, and also you will give it to a loudspeaker, and you will try to see how does that sounds like. That almost sounds like what we hear today. So you will have almost a real time exposure, right? So that's all about today. So there are some technical things you need to remember. The EMG signal frequency range is 15 kilohertz, right? And the frequency is high, so you cannot have a plotter, and then you need to have a loudspeaker. You can see that the EMG signal picked up by the electrodes is in the range of 1 or 0.5 millivolt. So that's all. Any suggestions?
Sir, I have few suggestions.
Yeah.
So in block diagram, so you mentioned So the type of device will be looks like an band-like structures. So the electrode will be looks like band-like structure. So in animative 5, you shown some electrodes directly placed in our human body.
Yes, yes.
So what is the difference between these two?
Actually, that here they have used the surface electrodes. So just to see, it's actually a project. You can see that they are visualizing in the mobile. So this is an Arduino-based project like what we do. So they are paid to pick up the signals. But this is not what actually the doctors do. They do with more sophisticated equipment. So here it's a simple Android phone, and we tend to have a surface electrode and pick up a signal. So this is not professional electromyogram. So electromyogram is an equipment, so where you will have that kind of electrodes. This kind of electrodes, where you will have patch of electrodes running. So from there you will try to. So that is a simple project, but they are doing in the real time. So I try to show it. Even we can try out such projects once we are in the phase of completing research.
So whether you have planned any industrial visit?
Yeah, industrial visit we have planned to take to Royal Care hospitals and Gem hospitals also. I'll talk to the doctors, so because both the hospitals have all the kinds of recording. So whosoever tends to give us permission for electromyogram, we can go and take a visual exposure.
So
Thank you.